Hey geometry class, this is our section 6.3 lesson, and we are going to be proving triangles similar by what's called angle is what that stands for. And that is going to be one of our postulates in this section, and we're going to use it in a proof at the end, but in between now and the end, we are going to be applying this angle similarity postulate. So let's go ahead and get started. Before we look at the angle similarity postulate, we're going to look at this example right here. This is just a warm up for us to get us started on thinking about similar triangles. So this is something that we learned in the previous section. It says here, part A, we're going to be using the figure over here. It says triangle ABC is similar to triangle DEF. And it says list all pairs of congruent angles. So by now, if we know what triangles is similar to what triangle, we should know what angles are similar to what angles in the triangle. Okay, so we're going to start out with angle A is congruent to angle D. Just go in order. And then angle B is congruent to angle E. Angle B congruent to angle E. And then lastly, angle C congruent to angle F. And there we got it. Now on part B, it says write the ratios of corresponding sides in a statement of proportionality. Okay, so in our statement of proportionality, we look at our corresponding sides of our triangles. So similar to what we did for our angles up here, I'm going to go and mark under 2 because putting two letters together here creates a side of our triangle. So AB is corresponds to DF. So write that as a ratio. AB over DE. And that is going to be equal to, let's do that again, but with the next two letters, starting with B and BC and now EF. BC and EF. Notice how if I start with AB, the first triangle mentioned here, and then write aside from the other triangle, I have to do the same thing in my next ratio. So I write something from this first triangle mentioned and then over the second triangle mentioned. And that's how I'm going to do my last statement too. My last ratio here is going to be, I'm going to use CA and then FD. So CA and FD. And I'm done with my statement of proportionality there. Now on part C, we have some numbers here, and it says find X. So we already know that CA here is corresponds to FD. So let's write that in a ratio. CA is 12, and then FD is 15. And that is supposed to be equal to, now let's list another pair of sides, like BC over EF, because we have those links and we're asked to find what X is. So BC is 8 over EF, which we call X. Now at this point, do your cross multiplication. So multiply this and set it equal to these two multiplied. So 12x is what we get. And then that is equal to 8 times 15, which is 120. Now divide both sides by 12, and we get x equals 10. And we are done with that example. Okay, so here is our angle similarity postulate. It states, if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. So this is just another way to show two triangles are similar to each other by knowing that this right here described. This angle is congruent to this one. This one is congruent to this one. And in a previous chapter, we learned something called the third angle theorem. If we know two angles are congruent to another two angles in a triangle, then the third angle is congruent too. So if all angles in both of our triangles are congruent to each other, all corresponding angles are congruent, then we have congruent triangles. We don't necessarily have to measure the sides. We know that all angles from one triangle are congruent to all the others in the other triangle. So we have similar triangles. So let's use this in an example. So here in example 1, we're asked this right here. It says determine whether the triangles are similar. If they are, write a similarity statement and explain your reasoning. Okay, well, by the angle, we only need two angles from each of the triangles that are congruent to each other. So here we have angle D is a right angle and angle G is a right angle. There's two corresponding angles right there that are congruent to each other. Well, let's figure out what angle K is. This right here is 26, and if we figure out that K is 26, then we have congruent, or not congruent, but similar triangles here. So the way we find out what the third angle is here is we can do it two ways. If this is a right triangle, we know that H and K here are going to add up to 90 degrees. So angle K, I'm going to say this right here. Measure of angle K is equal to 90 degrees minus 64 degrees. Well, that there is 26 degrees, which is congruent to my angle C up here. So since angle C and angle K are congruent and angle D and angle G are congruent, by the angle, we have similar triangles. So let's write that in a statement. This is how I'm going to want you to write it on tests to be able to explain your reasoning or determine whether the triangles are similar. This is how you need to write it out. So since we know angle D is congruent to angle G, and it lists another congruent angle, or another pair of congruent angles. Angle C is congruent to angle K by angle, and then it says write a similarity statement, meaning what two triangles are similar to one another. So by angle, triangle, I said CDE is similar to triangle KJ or GH. Now, just like a congruent statement, your angles have to correspond to each other. A similarity statement, all your angles have to correspond to each other too. So C is congruent to K. We figured that out. D is congruent to G. Well, we know that. And we should know that the third angle, E and H, are also congruent. So there is our similarity statement and our reasoning behind it. All right, in example 2, we're going to be using the angle similarity postulate to help us in answering all of these questions that I have for you. So triangle ABC is similar to, and we're going to list the proper angles in order to make this similarity statement. So triangle ABC, and now we know F is congruent to A, E is congruent to B, and D must be congruent to C. So list that in that order, F, E, D. and we're done with that one. Now let's go over to 4. This is asking us about the ratios of make a statement of proportionality with these corresponding sides that we know correspond to each other. So AB, well, right here, or BA, that corresponds to FD, or FE, sorry, or you can write EF. AC, let's see, AC, these last 2 letters correspond to F and D. So write that down, FD. And then CB, let's write it like this. CB and DE correspond to each other. So DE, and we're done with that one. Now number 5 and number 7 goes along with this one. We have 25, so this side right here, and we're going to place the number from FD because these 2 sides correspond to each other. So write 15 under the 25. And then let's see, corresponding to side that says 12 right here is Y. So place that above the 12 and you got your similarity statement to help you in, your proportionality statement that is going to help you in solving for Y. So let's go ahead and do that. We can do cross multiplication here, or we can just simply multiply both sides by 12 to cancel this out right here. And all of this, 12 times 25 over 15, that will get us 20. Okay, let's do the same thing with 6 and then 8. So number 6 here, let's see, it says 25. Well, we already said 15 was the corresponding side, so put that above 25. And then 18 over what? So 18, the corresponding side for that is BC. So write X. Now here, do some cross multiplication. And let's see, cross multiplication will get us 15x equals 450 because 25 times 18 is 450. Now divide both sides by 15 and we get this right here. X equals 30. So right here, we get 30 for X. Okay, so that is somewhat of what you would see in your homework. And now we have an example here that is an application to what we are learning about. And in example 3, this says a flagpole casts a shadow that is 50 feet long. At the same time, a woman standing nearby who is 5 feet 4 inches tall casts a shadow that is 40 inches long. How tall is the flagpole to the nearest foot? Okay, so what we have to do here, my suggestion would be draw this out. Okay, so an example of how I would do this is, okay, so we have a flagpole standing here, and it's casting a shadow right here that is 50 feet. We don't know how tall the flagpole is. That's actually what we're looking for. I'm going to connect these two right here. Now we have a woman who is standing nearby who is 5 foot 4 inches. So 5 foot 4 inches, if you convert that to inches, that is going to get us 64 inches. Okay, so let's say this woman is standing right here. That represents the woman's height is 64 inches. And her shadow is 40 inches long. All right, so if on this triangle right here that we just drew, we know these triangles are supposed to be similar. That's what you're going to get in this chapter here are similar triangles if you come across a word problem like this. Okay. This triangle is being measured in feet, this triangle is being measured in inches. There is no conversion needed except for this part right here. We need to have the same inches or feet on each of your triangles. So if the shadow is in inches, we need to make the height in inches. And then over here, when we go to figure out what x is equal to, the unit of measurement is going to be in feet also. And just like the shadow being casted was measured in feet. Okay, so now let's figure this thing out. Since we know these triangles are similar, um, let's write their ratios of their corresponding sides in a proportionality statement. Okay, so we can say x over 64 is equal to 50 over 40. And then we can just do our cross multiplication, or actually this time we can say, since x is in the numerator here, we can say multiply 64 on both sides, and we get 80 for our answer. And that is the unit of measurement, remember, is in feet. So x here is 80 feet. And that is how tall the flagpole is. Okay, so let's do the last example I have for you. All right, as I said at the beginning, we were going to have a proof at the end of this recording. So this is your proof, and this is what I'm going to tell you to write down as the given information. This is just explaining right here of the drawing that I have over here on this side of the screen for you. So as statement 1, write down that angle RPT is congruent to angle RSQ. And let's identify which angles those are. So right here is angle RPT, and right here is angle RSQ. Okay, now to prove two triangles are similar to one another, so far we've only learned angle, angle, and then we've learned the definition of similar triangles. And this one right here will be proved easily by angle, angle. We only need one more angle in each of these set of triangles to show that these two triangles are similar. So the angle that they both have in common is angle R. So like we've done before in triangles, we can say this right here, that angle R is congruent to angle R. Now this right here was given. And so this right here is our reflexive property of congruent angles. So just state reflexive property. And that's it on that one. So on statement 3, what you need to do is now, since you have two angles in each, where's my pen? There it is. Since you have two angles, 1, 2, and another set of angles that are congruent to each other, these two triangles are similar. So just say triangle, the statement right here that I underlined earlier. Triangle PRT is congruent, or not congruent, but similar. Similar to triangle SRQ. Now, statement 3, the reason we know this is because of the angle-angle similarity postulate, but you only need to write AA, and that's it. So, we will work on these assignments in class that are very similar to these problems here, and I will see you all. Goodbye.